In this video, we're going to cover some of the technological advances that have occurred since Wegener's time. We'll talk about some of the early technology that I've already mentioned in other videos. We'll look at the global positioning system, seismic waves and the measurement of seismic waves, vibrators mimicking seismic waves, and deep ocean buoys. So when Wegener originally proposed his theory in around 1910, he was shouted down for not having enough evidence to support his theory. And we've already talked about some of the evidence that later became available. For example, Harry Hess mapping the ocean floor and finding the mid-ocean ridge during World War II, and coming up with the theory of continental drift in the 1960s, as well as the magnetic striping of the rocks on the ocean floor, which were discovered in the 70s. Today we have even more technology than this. For example, the global positioning system, which is a system that uses satellites that are in orbit around the world with GPS trackers marked at various spots in the world. And what we can do is very accurately measure the position of those trackers and how they move relative to the others each year and relative to other places. So we can actually see the speed of multiple places on one plate and therefore average out the speed for the plate. And this is a diagram of that. Seismic waves. When earthquakes occur, we can also use the seismic waves to collect data. Due to the different properties of the waves, so the 4 different types of waves, using multiple seismometers, we can work out the internal structure of the Earth. And this might be something as simple as the 10, 15, 50 kilometers below us, or it could be looking right into the internal structure on the Earth, depending on firstly the size of the wave caused by the earthquake, as well as how many seismometers we're looking at. As these waves move through different mediums, they refract, so bend, or they can be reflected off some mediums. So we can actually work out where these mediums are and where the edges of these are by looking at this refraction and reflection. And we also these days don't even need to wait for an earthquake to occur. We have machines, and we call them vibrators, and this is generally mounted to a truck which has a big pad that slams into the ground. And before doing this, they'll place out lots of very sensitive seismometers called geophones, and then analyze the waves produced, again using the reflection and refraction to see what's inside the Earth. A way that we can measure the waves moving around the Earth in the ocean is by using deep ocean buoys. Now, deep ocean buoys consist of 2 parts. One is a pressure sensor that sits on the sea floor, and the other is a buoy that floats on the surface. And these measure 2 things. They measure the sea height as well as the amount of pressure occurring at a particular point. So these can pick up tsunamis caused by earthquakes, as well as picking up smaller waves and tremors from small earthquakes. So all of these different technologies go into our understanding of the Earth's structure, and in particular, for this topic, our understanding of how plate tectonics works. In this video, we've recapped some of the early technological advances, such as Harry Hess mapping the seafloor, as well as the discovery of magnetic striping around the mid-ocean ridge. We've talked about the global positioning system, measuring the position of cities and places very accurately and tracking their movement, whether it's 3 or 7 centimeters per year. We've looked at how we can use seismic waves caused by earthquakes as well as the reflection and refraction of those seismic waves inside the Earth to determine the structure of the Earth. We've looked at using vibrators mounted to trucks to mimic seismic waves, as well as the use of deep ocean buoys to measure seismic waves in the ocean, as well as measure and predict when tsunamis are going to occur.